Hello, hello. So we were talking about building our own interpreter in the last video. We'll be coding it in this one. We'll start coding it in this one. So let's get into Code Crafters and create a repository. So I've started a new repository and let's just read. This challenge follows the book Crafting Interpreters by Robert Nystrom. In this challenge, you'll build an interpreter for logs, which is a simple scripting language. Along the way, you'll learn more about tokenization, AST, tree walk interpreters, and more. Before starting this challenge, make sure you have read welcome part of the book that contains these three chapters. Highly recommend it. It gives you the theoretical background required for this challenge, but most of the things I will let you know. I will let you know the entire context-free grammar. I'll explain it. I'll explain the tokens, everything. Mostly I'll try to, but I still recommend reading at least the map of the territory and the logs language. The logs language just to know how the log scripting language looks like. That's primarily the concern of this chapter. You should definitely go through it before uh, starting this challenge. These are links and you can open them, and you can even read these for free, I think, on Code Crafters. Yeah. Yeah, you can start this challenge and read these for free. So anyways, you should be able to do that if you're just coding along with me and not actually doing the Code Crafters challenge. But I do recommend that just so you know you're doing the right thing because they do unit tests on your code. So I'll be doing it in Java and I'm an intermediate. Next question. I do it every day and I'll pass. Alright, this gives me a link. So open a terminal in any directory that you want. So my terminal is already open. Just copy the commands and paste them. So this creates the repository for you. CDs into that repository, and I'm not going to, oh, these are okay. Yeah, just copy these commands, paste and enter. This initializes your repository on Code Crafters and it starts your challenge, and with this you can go on to the next one. Now I'm not using VS Code, so I'm not going to paste this command. You should if you are using VS Code. I'll be using IntelliJ. uh, okay, so mark it as complete. So all we need to do is remove this line. So let me open the code first. So I'll copy the path. Open. All right. We are here, we're into the code, and what we need to do is go into main.java and remove this line and uncomment this code. With this, you can commit and push your changes. That's all you need to do to pass the first stage. And you can do a git push. And let's go through the code. All right, so they start the program and the program accepts two parameters. If the length of the args is less than 2, we exit out of the program. And what if it's more than 2? Then we are not using the third argument at all. We're just using the first two arguments. And the first argument is the command. If it's not equal to tokenize, unknown command, and we're exiting out of the program. And the second is the file name. So let me tell you what that is. They're going to test your code by giving it two arguments. They're going to run your code with two arguments. The first is going to be a command, and the second is going to be the name of the file, like how you run a Python file. Python something.py, like that, node something.js, like that. So it's kind of like that. Tokenize test.logs. And that's how they are going to run your program. And so the second argument is the file name. And then we have a string for content. They are reading the contents of this file using file.readString. And if it throws an error, we are exiting out of the program. And let's just remove this. So if the file contents.length is greater than 0, if there is some content currently that is not supported, and if the content is 0, there is nothing in the file contents, then we system.out.println EOF, meaning end of file, and a null. All right. So that's the code that they give us, and we have to build upon it. All right. So I think it should be simple. Let's just read. What they tell us. In this stage, you'll implement tokenize command to handle empty logs files. The tokenize command, is a program. Tokenize is a program and prints the tokens to standard out. We'll use this for testing all stages in the scanning chapter. In this chapter, after this, in parsing expressions, I don't think they're doing that. All right. If there's a file name test.logs with the following content, the tokenize command will return the following. So var null, that's the so the var is the type of the first token. Var is the lexeme, like what actually is the token. And this null indicates that this var doesn't have an underlying value in the language we're implementing it. So if it were a number, if this token was a number, then its type would be number. The second thing would be the number like 1.2, and the third thing would be the underlying object in the language we are implementing this language. Like I am implementing this language in Java. So this third thing would have been a double object, an object of the class double, right? That would be the third thing. That's how they're basically following this from the book that they recommend to read. And that's how I know this stuff. That's how the author of the book has written it. The output format matches the spec in the book's repository. So this is the repository of the code that this is the author of the book. So you can go through it. I don't know. I read the book, so I don't need to. You should read the book as well. Each line corresponds to a token in the file var language equal logs. So okay, so now you see the second is a variable, and the type of the token is an identifier. We know that. The second thing is the value in logs, and the third thing is value in Java, the thing that's implementing this language, right? Similarly, the third thing is an equal. This is how it looks like in logs, and this is how it looks like in Java. We do not have an underlying value for it in Java. It's just token that drives behavior of the language. Then the fourth thing is a type of string. This is how it looks like in logs, and the underlying value in Java would be the string without the quotes, because in logs a string looks like this, but to actually use the string, the user doesn't expect the double quotes to be part of the string. So that's why the underlying representation in Java would be this. I'll create a string of LOX, and that would be a string in Java. And whenever the user refers to the person writing the code in logs refers to language, the underlying value of LOX in Java would be used. That's what this means. And we have a semicolon, it doesn't have a value in Java, and then we reach the end of file. So you should definitely read the book if you do not understand what I just said. So we have a language, logs, and it's being implemented in Java. All right. So we have constructs in logs, and then we have equivalent constructs in Java. I'm using Java as a backbone for logs. All right. So that's what these things tell you. The type is the type of the token. This type is required for parser to know how to process this token. Then the second thing is the representation in logs, and then the third thing is the representation in Java. All right. Each line corresponds to a token in the file, image from, This is the format, token type, lexeme, and literal. token type, types of token, lexeme, actual sequence of characters that formed the token. The literal value of the token. By the literal value, they mean the value of the token in the underlying language. If locks was being implemented in a language that was just binaries, zeros and ones, then the literal would not be locks. It would be the binary representation of locks. All right, that's what it. But we are implementing in Java. That's why the underlying representation is locks. But if it were being implemented in a binary language, then the underlying representation would just be a sequence of zeros and ones. And the EF token is a special token that represents the end of the file. So the user writing the logs code would never write this token. We need to append this ourselves. So at the end of our scanning, when we have gone through the entire code, we will add this token by ourselves. It will not be in the file that they give to us. All right. And again, this will mark the end of scanning, and it will be used to terminate the parsing as well. So they run the program, they run the program with two arguments, tokenize and a file name. All right. And it will print this, and that's what our code prints as well. You can probably see it in the logs. See, your program, it printed EOF null. So right now we haven't done any code. We are just exploring the code that they have given to us, right? And with this, it completes this stage, and we can proceed to the next one. So in this stage, we'll start recognizing tokens. So the first token we are working on is the parentheses token. It looks like this, and the closing one as well. So left and right parentheses, and their types are left paren and right paren. Their locks representation is this, and they do not have an equivalent Java representation because they don't need one. We don't process this. They don't require to be processed. All right, in Java, like a number would be or a string would be. So that's what. So if the test.logs has this, the tokenize command should return this. Oops. The tokenize command should return this. So the code for this stage is implemented in, so you can go ahead and read the author's implementation, but I guess you are watching my video for my code. So it's going to be a bit different from his. It's majorly inspired from his code. And what I've done just some architectural changes, a little bit. See, if you go through his GitHub repo, he has coded everything in a single Java package, and I personally have trouble following code like that. I want some semantics built into my package system as well, the tree of my package. So I will do that. Uh, I will refactor this code that they have given in the main class as well, somewhat in this video. So let's just start doing that. So the first thing I'm going to do is create a package called as lexicon, and this package will have everything related to the lexicon of the language, the alphabet, the type of the lexicon. So this package is going to be called lexicon, and in this lexicon we're going to have a few classes here. All right, so I'm going to first have a token class that will represent the token. And what we'll do is I will override the toString method in this class to give us this output. So we can simply print the token and it will look like this. So in the very least, my token class should have a type, a representation in locks, which the author has called lexeme, and the representation in Java, which is called a literal. So this should have a token type. Now the best way to implement types is through an enum. So we'll do that, an enum, and I'll call it token type. Token type. And in my token type, right now all we need is left and right paren and an EOF as well. Left and right paren and EOF. That's all we need in my tokens right now. We'll add many more things to this token type. And in this class, I'm going to have a private final token type. I'll call it type. We're going to have a private final, the representation in, oh, we need to have a string lexeme for the representation in logs, and then we need a representation in Java, and that would be an object, because we need it, because it needs to be generic. This literal can be either a string or a number or some or an null. So object will work for that. Object type, we'll call it literal, and we'll add one more thing. And this is not required of us right now, but it's going to be very, very helpful for debugging purposes. All right, we'll add a field called public final integer line. Why is that? Because I did not come up with this myself, right? So I read the book and the author did this as well. And I actually did find it to be very, very helpful for debugging my code. And so that's why I'm keeping it here as well. We create a constructor, and like I told you, we're going to override the toString method. So public string toString @override, and from here we're going to return this format. So this is going to be token type, token, oh sorry, type plus space plus the lexeme plus space plus the Java representation, which is the literal. Oh, sorry, literal. So that's our toString. Okay, and that should be it for token right now. We don't need to add anything else, and that's it for token type as well. Now, one thing I should let you know is, since you know I have gone through the book and I have I have knowledge already of what's going to come up next, so I'm able to plan things that Codecrafters is not asking us to do right now. But it will be helpful to do to set up those things in the beginning. So I will create a custom class, a custom exception, all right, and it's going to be a scan exception. So when you run a code, when you run a Python or a JavaScript file, what do you imagine should happen if the scanner for that language throws an error? Should the interpreter start running the file if the file is not correct? No, right? So this exception will be able to, will allow us to uh, stop code execution if there is an error in scanning. Right. So if I see an error in scanning, I will just throw this exception, and that should stop the flow of my program of the interpreter, and that would not execute the code. So that's how these exceptions are. These exceptions are going to be used for control flow, basically. These are not exceptions that the end user who's writing logs should see. I mean, they should see some message kind of, right? So I will give it a message like scan error at line this. So scanner, that's why the line thing was necessary, because we need to tell user that they have an error on which line. So this scan exception will print that to the output console, but it's not something that the end user should know. So I will use this message to print, but this exception will be caught, will print out the message, and will break the code execution. That's how this exception is going to be used. So we have a token class, we have a scan exception, and now what we need is a scanner class. So this is going to be our Lexer. So I'll just What should we call it? Should we call it a Lexer, or maybe I'm wrong about what a Lexer is. What is a Lexer? Is a program or function that breaks down input text into a sequence of meaningful units called tokens. So we should probably call it a Lexer. And if you are aware of Java, then you should know that there is a scanner class in Java. This is, I think, essentially kind of like a Lexer. So it reads your input and it breaks it down into tokens, but it scans English, kind of like not English words like broken by spaces. The default delimiter is empty space. So a Lexer is that. So I'll just call my class a Lexer. All right. So this is going to be a Lexer, and we're going to use this in our main class. All right. So if the command is not tokenized, I'm throwing an error, and this file content, I do not like it here. So I'll move it to someplace else. Uh, I don't like this file content. So what I'll do is I'll copy Control X this, and I will create a class called a runner. And it's going to be the responsibility of this class to actually run code. So I will call runner dot run, and I'll give it the file name, and it's the responsibility of this class to run this file. And I will paste what I copied from there into here, and I can remove the packages from here. All right. So given the file, so this will read the file contents, and right here. Now, see, you see scanner not implemented. Now what we're doing is we are implementing the scanner. So this is where our code needs to be. So right here, I should create an instance of the Lexer. Lexer equals to new Lexer, and Lexer dot scan. And I think we should parse in the file contents as well. And this should return a list of tokens. I'll call it tokens. And since we have overridden the toString method, we can simply print the tokens, and it will be the format that they require us of. They require of us, sorry. Tokens, and I can sout a token. All right. So now I need to create this constructor. And what is this? Replace with empty string. Let's go back to the Lexer. So Lexer, this should be in a private final string source field, source equal to file contents. What's the issue? Convert field to local variable, but never accessed. All right. And now let's create this method, scan. All right. So right here, what we're going to do is we're going to scan all the characters in our source code and convert them into token objects with the required type. That's what's required of us to do right here. Okay. All right. So we are going to implement it with pointers. Since it's a string, to go through the string, I need a pointer. And let's just call that a private int current for the current character, private int start to point to the start of the token. So some tokens are multi-character, like if is a multi-character token, for is a multi-character token, while is a multi-character token. So what I'm saying is, so in this case, start should be right here, and our scanner will S is right here, and so is current. All right. So let's imagine we are scanning this. Our current would be here. We see a W, we process it. We see a H, we process it. We see a I, we process it. We see an L, we process it. We see an E, we process it. Now we realize we're at a reserved keyword. So if the next character is an empty space or some other token like this, we know that this should be a reserved keyword and this should be a reserved keyword type. So to be able to get this string, we'll do a source.substring, and we'll do a source.substring starting from S to current. All right. And that will be the token Lexeme. And after this, after we have extracted out the token Lexeme, we'll set start back to current. And then we can start processing the next tokens. All right. So right here, that's the start. That's what this start field is for. And again, we need a field to tell us which line we are processing. So we'll start processing with the first line. All right. So that's the constructor, and this token, this scan method is supposed to return a list. All right. So this, an object of Lexer will only be able to scan the contents that we gave to it at the time of instantiation, sorry. So it should return, uh, so that's why we can make this field a class level field, private final list, because it's not going to scan any other thing. It's going to scan the content we are giving to it. All right, nothing else. Token, and let's call it tokens and new array list. All right, and this scan is going to return these tokens. But before returning the tokens, I told you we need to add a new token of type EOF. I told you that, right? So new token of, so the first thing is EOF. Then the second thing is the token itself, but what's the second thing in the constructor? It's the Lexeme, then the object, and then the line. Lexeme. What's the Lexeme of null of EOF? Nothing. What's the literal of EOF? Nothing. And the line is going to be the line where the source code is ending. So we need to add this token to our list of tokens. And right here we can start scanning. So we will scan until we reach the end of file. And the end of file will be determined by if current pointer is at the end of source. While current is less than source dot length. With this, all right. Now we need to, like I told you, the current will see a W, then it will see an H, then it will see an I, then it will see an L, then an E. So we are processing these characters one at a time. So I need a way to get, so we need to get the character out of the string and move the pointer forward. At the same time, we should encapsulate that into a single operation. So we'll do that. Public, it returns a character, and I'll call it get current and move to next. Alright, what this does is it returns source dot char at of current plus plus. So it moves the pointer forward as well. And to get the current character, I can char current equals to get current move next. So this moves the pointer one forward. So let's say we were parsing. So we are parsing right now. We are parsing this, right? So our start is going to be here and our current is going to be here. So this should have returned me the opening braces and moved the current pointer forward. All right. Right here, I think I can add a switch case, or what I can do is I can, hmm, I'll create a method, because if I add a switch case right here, this function is going to become quite long and I don't want that. So what I'll do is I'll create another method called scan and I'll pass it the current character. Uh, Seems fine. And it's the responsibility of this method to go through to process the characters. All right. Okay. And then we need to add, we'll do that in this method itself. Create method scan. So right here, I'll add a switch case on the current and I'll add a case for opening parentheses. I'll break out of it and we need to add a case for closing parentheses as well, just so I don't forget. And right here, I think we should encapsulate this logic into a method as well. Token type and then the lexeme and then the literal, then the line. And token literal. Okay, so this line is doesn't need to be passed. So what we'll do is I'll create a method to add to this list as well. This should be private. Private. And this method doesn't returns nothing. Add token, and this method needs a token type, and object literal. So whenever we encounter a number when parsing, we'll eagerly convert it to a double object and add it to the list of tokens eagerly. So that's why I'm encapsulating it right here. So by mistake, we do not add to a list like this. We should only be using this method to add to the list. And so what we can do is add token, and token type is EOF and the literal is null. All right. The literal is null. String lexeme. I told you we'll be extracting the lexeme from the source code using a substring starting from S going to C. Starting from start and going to current. That will be the lexeme. Is this the lexeme? So the first thing is type, then we have lexeme. So Lexi, it should be empty. All right. And object is literal is null. All right. And the line is line. Type and literal is this. What? Inline value of parameter type is always EOF token, because sometimes I hate modern IDs. In this case, we're going to call it with a left paran, then the literal is null, and in this case we're going to call it with a right paran and the literal is again null. So let me import all these types statically. Import token type dot star. Token types are in lexicon on dot token type dot star, and I think I can remove this static import, sorry, and just make it star. With this I can remove this, and with this I can remove this. All right, now our scanner seems fine. It adds the token, and then we add this. I think this should be it. Let me check. Why is it throwing an error? Is always null because I haven't used it yet. I will use it later. Shut up, IntelliJ. Please stop giving me warnings. I know what I'm doing. I'm not idiot. I am, but not right now. Okay, so let's try pushing it to code crafters. Git commit -m scanning parentheses. Git push. Does it work? Moment of truth. It doesn't. Why doesn't it work? My program printed left paran and nothing else. Why? And what was expected? EOF. EOF? And I added a token of type EOF. I scan and I break. What is the damn issue here? Why is EOF? So when I scanned this add token, it was at there. Okay, so after scanning, it should have moved to the end, right? So EOF, 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 EOF. I don't think we can do it then. If EOF is at the last third, but start doesn't move ahead, right? Oh, I think I know what the issue is. Okay, so I know what the issue is. So the issue is file looks like this. All right, we have a start and we have a C. So when we do get current and move next, it returns this character and moves C forward, but it never moved S forward. So S never moved forward. So, and since lexeme is extracted before adding to the list of tokens, it again scanned this. So after we scan a character successfully, we should increment S to C. So start should now be at C. If you have scanned this token successfully, start should move forward to the starting of the next token. So if it were a multi-character token like for, so okay, we'll get to that later. We'll get to that later. I know what to do, but we'll get to that later. That will be handled. Right now, if I tell you, you'll be confused. So that will happen after we scan a keyword. After we scan a word, then we'll check if it's a keyword. So if the current character doesn't is not a particular token of like reserved characters like parentheses or braces like that, if that is not the case, if it's an alphanumeric character, then it can probably be part of a variable name. So we'll extract a word out and then we'll check if it's a keyword, then we'll handle keyword separately, and that we'll do here, not here. So right here we are safe to put start at the current, because if it were a for, let me tell you, if it were a for, we'll see there will be another case right here that will be handling words. All right, and in that I will check if keywords dot contains this word, then I'll know it's a special keyword. And right here, then I can handle the for case. Like, see, right here, what we'll do is we'll have another loop here. All right, we'll have another loop here, right here, in another case below it, below this one. There will be another case that will be handling words. All right, and in here we'll have another loop and we will extract out all the tokens from it till we see a delimiter, that is an empty space, till we'll add all those to a string that will give us the word. I'll check if keywords contain those words. So you see, in this loop our current pointer will keep moving forward. All right, so by the end of it, current will be pointing to the end of the token, end of the entire token. So instead of calling it scan, I should call it handle token. All right, handle token. Okay, good. And since I told you current will be pointing at the end of the token, we are good to put start back at current. So we'll move start. So if current is here, like for current is here, then we'll move start. Yeah, so this is fine. So after handling token, current will be here. So we're good to put S here again. So that's what this line is doing. I wanna know what love is. So, our code works. Haha, we passed it. Come on, let's go. Okay, that was it for this video. In the next one, we'll be handling braces, and maybe we can do it right now. Let's just do it right now. So in the token type, we'll add other types like left underscore brace, comma right underscore brace. So it's the same thing. Instead of parentheses, we're handling braces. All right. It's just essentially the same thing. And we can just copy it, paste it right here, convert it to a brace, convert it to a closing brace, and instead of paran, it is a brace, and instead of paran, it is a brace. And I think this should work as well. Git add, git commit. Huh. Oopsie daisies. Yeah. push. I think this should work. It works. All right. Uh, we'll move to the next one and see if it's anything new. Uh-huh. So in this stage, you'll add support for scanning single characters, namely commas, dots, minus, plus, semicolon. So we need to add all those to the token type. So it's just grunt work. We need to add all these tokens, all these token types to our token type enum, and just need to add cases to a switch case. So we'll quickly do that in the next video, and then we'll handle, see, lexical errors. So we'll handle those errors and these tokens in the next video. That's it for this one. See you in the next one. Find the code to the repository down below in the description or something like that. Bye bye.